Hey everybody, my name is Ashley, and as Justin said, I'm here to talk about WebAssembly. But as you can tell from my incredibly long talk title, I'm also here to talk about several other things, including Rust and JavaScript. So the first thing I wanted to know is how many people here have written any Rust? All right, how many people wrote that Rust to compile it to WebAssembly? Heck yeah, that's so exciting. Cool, how many people have done anything in WebAssembly? All right, hopefully by the end of this talk, I've convinced you that it's actually worth trying now. One of the biggest problems about this topic is that I'm here to talk to you about Rust and WebAssembly, which are both incredibly new, kind of like edgy things that most people haven't used. And this is supposed to be a practical conversation about technology you can use today. And so I'm like, I'm going to take these two things that were born like pretty recently and try and explain to you that you can absolutely use them. And so that's a bit of a challenge, but we'll see. Additionally, I'm really excited about this talk because I'm going to go into some depths of things. And I was going to do that because I was told that I could do some workshops, and they would be before the talk, and so that would help everyone get up to speed. But the workshops are actually after the talk, and so it's just going to be a little in between. But hopefully, I'm going to go try and go a little fast because I feel like WebAssembly is one of those things where people want to ask questions a lot, and so hopefully I can make some time. All right, so I named this Rust, WebAssembly, and JavaScript Make 3 an FFI story. How many people here just knew what FFI was when they saw me list it? All right, cool. That's awesome. So the FFI I'm going to be talking about is slightly different than the one that you might expect. So FFI stands for Foreign Function Interface. And classically, you got to do the really scientific Wikipedia definition. So a mechanism by which a program written in one programming language can call routines or make use of services written in another. And so you may note that I actually had 3 languages written in my title. And so some people may think this is a talk about how to teach Rust, how to JavaScript. And believe it or not, this is something that exists, but it's not what this talk is about. So if you want your Rust to talk directly to JavaScript, check out Neon. Arguably, I would say it's a little bit slow. You're going to want to use the WebAssembly version, but Neon is also very cool. This talk is going to be about how we teach WebAssembly to talk to JavaScript using Rust function signatures. And if that sounds super intense, I'm hoping by the end of this that you will actually realize that not only is it really not all that technical, potentially a little bit tedious, but actually kind of exciting and something that you can actually look into and kind of understand on your own. Let's see how well I do with that. All right, so my name is Ashley Williams. This is a picture of me dressed as a crab. If you're unfamiliar with Rust, Rust has an unofficial mascot called Ferris, who is a crab because Rust people are called Rustaceans, and the puns get worse, so I'll stop there. But I am on the Rust core team. I'm also on the Rust WASM core team. I wrote this tool called WasmPack. If you've written Rust-generated WebAssembly, you've almost certainly used that. I used to work at NPM and Node, so balancing this Rust JavaScript game is my jam. And I currently work at a company called Cloudflare on building out more WebAssembly tools. If you want to learn how to run WebAssembly on the edge because, again, more edge technologies there, come talk to me because that's what I'm working on. So as I said, today we are going to talk about how we can connect all of these 3 things and make them live very happily together on the web, being very, very small and very, very fast. But before I do this, I think it's probably important to kind of explain what some of these technologies are. So what is Rust? So on its website, Rust declares itself as a programming language designed to empower everyone to build reliable and efficient software. So fundamentally, Rust is kind of, you could understand it as a kind of C++ replacement, but instead of being C++, where maybe you could shoot yourself in the foot and the tooling is kind of terrible and the docs are kind of terrible, we actually make the tooling really, really nice, the docs really, really nice, because we want literally everyone to be able to program at a systems programming level. And in order to do that, you have to make your environment inclusive and a great place for people to learn. And so that's what Rust is really trying to do, and it's what really inspires me about Rust. But some people like the technical details, so here are a couple. We are statically typed, but we also have type inference. You can say let name equal quotes Ashley, and you can get a variable. But the biggest thing that people really pay attention to about Rust is we have a concept called ownership and lifetimes, which gives us this guaranteed memory safety without a garbage collector. If you want to be really pedantic about it, we actually kind of have what you could call a static garbage collector, which is really a blood pact with the compiler that says you'll write your code this way and I'll take care of it for you. But if you are a Rust newbie, don't worry about this. And people often say that this is scary. This is definitely the location of the largest learning curve in Rust. But you know, great responsibility, great power. And we're constantly trying to work on those docs every day. So some people like the Hacker News version of pitching Rust, and because I work at Cloudflare, I'm allowed to say this. But one of the reasons you might consider Rust for your company is Cloudbleed was an incredibly huge security problem that happened for Cloudflare, similar to the Heartbleed security vulnerability. And fundamentally what Rust says is the safest program is one that doesn't compile. So if you're doing some iffy stuff with your memory, unless you explicitly tell Rust, no, trust me, Rust is going to go, let's not do this. I'm not compiling this program for you until you fix it. So that's the orange website pitch for Rust. So with Rust kind of out of the way, let's talk a little bit about WebAssembly. So I asked people how many people here had heard about WebAssembly, and there were not that many hands. And so I'm going to go quite quick, but I'm excited to talk about this in the hallway if anyone wants to. So WebAssembly, if you go to webassembly.org, will say it is a binary instruction format for stack-based virtual machine, which is a tagline similar to the old Rust tagline, which has the problem that if you look at that, you may not be able to parse any of the words in it. And so a more friendly definition would be it is a compilation target for running bytecode on the web. So WebAssembly, of course, is on the web, and so people are always worried about reading source. And so it does have human-readable versions. You can see the top version is what you could call an S expression of WebAssembly. Who here writes Lisp? All right, it finally won. See? You got it. No. But yeah, additionally, you can kind of take a look. Down there at the bottom of the bytecode stuff, it also looks like that. But fundamentally, you're not going to be wanting to write WebAssembly from hand. You're going to be wanting to write it in a language that then is going to target WebAssembly as this compilation target. So don't worry, like, I don't know, I'm sure recruiters are going to be looking for people who have handwritten WebAssembly for the last 10 years, like tomorrow. But that's like not a thing, so don't worry about that. But another thing, just before I move on for this, I'm really excited about WebAssembly being on the web. But if we think about what's happened in the last 6 months, if anyone's followed the hype cycle with WebAssembly, the most fun things that are happening with WebAssembly right now are not happening on the web. And so a great tagline for WebAssembly is WebAssembly, neither web nor assembly. So just remember that, because again, naming things is very difficult. All right, so you might be asking yourself, cool, maybe I kind of have this idea of what WebAssembly is, but like, why? Why would you make this? Like, you could, but should you? And so there's a couple of reasons. This is one of the original white papers that announced WebAssembly. You can see that it's from a conglomeration of different browsers. So you have folks from Google, folks from Mozilla, Microsoft, and Apple all coming together to talk about this. And the primary motivation for WebAssembly is something like this. So if you read this, this is an announcement from Google I/O last year, where AutoCAD announced that you can now AutoCAD in your browser. And that's kind of a big deal. Perhaps this is very specific to me. My father is an architect. I remembered going to his job and having to run AutoCAD on like a Spark station. And so the idea that you could take that software that needed such a huge computer, like not a decade ago, and now you can put it in your browser is an incredible, incredible thing. So when I talk about WebAssembly, I like to try and motivate it when I define it. So I say it's a technology that invites new types of applications written in multiple different languages to be discovered and distributed on the web. Perhaps you can call me a millennial, but I personally think that it has been relatively proven that the web is by far the best discovery and distribution technology that has existed to date. And so if you want someone to use your thing, read your information, do whatever, it really needs to be on the web. And right now, because of the web's capabilities, there's some things that are just literally excluded from it because the browser and the web are literally not capable of being able to include those very performant, intensive applications. And so now WebAssembly is like, no, come on in. The web is also for you. So you might actually realize that this is not a new idea at all. Does anyone recognize these? Has everyone updated their Adobe Flash? No. Yeah, so this is not a new idea. In fact, it's an incredibly old idea. So Adobe Flash is that big red F there. This did not really have a logo, and so it's kind of an interesting one. But Google used to have something called Knackle, and they had a portable native client called pKnackle. And this was an attempt to do that as well. And then, of course, we had Java applets and all of those types of things. So why WebAssembly? Are we just repeating the same things that we did before? Is this a new Flash? And so again, I would just remind you, if we take a look at this, this is all the browsers coming together. WebAssembly has been formed through the standards process and continues to be. We'll talk a little bit more about that later. But this is like, what if Adobe Flash was something that everyone agreed on was an open standard and was open source and was inherently built into your browser. So as long as you keep your browser up to date, you should never get a little pop-up that asks you to update your WebAssembly, because that would be incredibly embarrassing. All right, so WebAssembly is exciting because it's inviting these new applications. But why is this important? Why is WebAssembly able to invite these kind of new applications into the web? And it's largely to this idea of speed and size. WebAssembly can go fast, and it can be smaller than JavaScript. And that's kind of the main idea. Now, I want to caution, with all new technologies, there's this question of like, well, how fast is it? And so we're definitely in a situation today where there are certain applications, because browser engines are really awesome, like V8 optimizes the heck out of things, where JavaScript will actually be a little bit faster. You know, the browsers now have to write WebAssembly optimization engines, and they haven't done that yet, or they're working on it. But in general, WebAssembly is going to be relatively faster because it's less code. It does not need to be interpreted because it's compiled. And it's going to be smaller because, remember I said it is a bytecode. So it has a lot less instructions. Again, wouldn't want to be writing it from hand because it's very unpleasant. But one way to be faster is just to be less code. And so WebAssembly is less code. But instead of me telling you all of that in an abstract sense, let's talk about a specific edge case. So Mozilla is one of the front runners in developing WebAssembly and getting it out there in production. And so this is a blog post written January 2018. So again, this is like OG WebAssembly days, by Nick Fitzgerald, who I work on with the Rust WebAssembly working group with. And he wrote an article called Oxidizing Source Maps with Rust and WebAssembly. This is a super awesome blog post, and I always show this graph. So these are a little maybe hard to see, but the orange dots are going to be measurements of JavaScript, and the blue ones are measurements of WebAssembly. These are all in milliseconds. And then across the bottom, the first two are Chrome, the second two are Firefox, the second two are Safari. So beyond going, hey, JavaScript and Firefox, what's going on there? What you might kind of immediately recognize is like, oh, cool, like the blue ones take less time than the orange ones. The WebAssembly is faster. But that is not what is interesting to me in this graph. Is anyone here on call? On pager duty? No? All right, so I used to babysit a whole bunch of node processes when I worked at NPM for the NPM registry. And this graph makes me get really excited about WebAssembly. Because check out that standard deviation, right? Oh my gosh, the performance of the WebAssembly is so much more predictable. Can anyone guess why? Garbage collection. So WebAssembly does not currently have a garbage collection. Memory management in JavaScript is going to be garbage collection, and it's going to be a lot harder to predict. But because WebAssembly does not have that, it's going to be significantly faster and significantly easier to predict its behavior. And so I think that over time, we'll see that WebAssembly is more consistently faster than JavaScript. But again, the killer feature really is its predictability. And I think that that is really great. All right, so immediately after posting this blog post, because it's the internet, another engineer who I really respect, but I'm very bad at pronouncing his name, so I'm just not going to. His Twitter handle is R Aleph. That's easier. He immediately wrote a blog post using the classic kind of meme phrase, maybe you don't need, and said maybe you don't need Rust and Wasm to speed up your JS. And if you are a JavaScript developer and you want to learn about V8 optimizations, read this blog post, because it is amazing. However, all of the things that he tells you to do to make your JavaScript faster makes your JavaScript inscrutable. It is impossible to read. It is very difficult to maintain, but you can learn a whole ton of cool stuff about how things get optimized. And so Nick followed this up by saying, hey, speed without wizardry. When you can write an application in WebAssembly, you can get this kind of speed and performance, but you can do it without having to use all of these fantastic optimization hacks. You can kind of just write your code the way you would write your code, and by using WebAssembly as this compilation target, you can kind of get that great stuff that you'd get from the hacks sort of for free. And what you might be realizing here is that there's a sort of sense that JavaScript and WebAssembly are at odds. How many people here have heard that JavaScript is going to die because of WebAssembly? All right. I'm going to say it like 8 times in this talk, but I just want to say it now. That's not true. And it's not what WebAssembly wants to do. So WebAssembly is not a replacement for JavaScript. In fact, it is going to be its complement. And the entire rest of this talk is going to be about an intense amount of effort from a relatively small number of people to work desperately hard to make sure that WebAssembly can play super nicely with JavaScript, because we believe fundamentally that is how WebAssembly is going to be successful. And we'll talk more about that. All right, so we fundamentally need that WebAssembly needs to interoperate with JavaScript. How many people here, regardless of what I just said, think that WebAssembly should kill JavaScript? Who's going to be bold here? All right, cool. This talk is for you. I'm so glad you're here. All right, so before I kind of talk about some more motivations, let's talk about technically what it means to make WebAssembly play nicely with JavaScript. So the first thing is actually kind of a little bit basic, which is like WebAssembly needs to be able to store and work with JavaScript objects. OK. Maybe that makes sense. We'll talk about the challenges there. And then additionally, JavaScript is very much an ecosystem-based language, right? We need to be able to interact with the JavaScript ecosystem via modules and workflows, particularly things like NPM and bundlers. All right? And so when I talked about a small group of people, this is the Rust WebAssembly working group. We meet weekly, and we post all our videos on YouTube. So if you want to hear these conversations, please go check them out. And we'd love for more people to get involved. But let's talk about the work that came out of this. The work I'm going to be talking about is primarily work that happened all last year. It was like a big year-long sprint to get this over the head. All right, so what I'd like to show you is I'm going to demo writing some Rust. I hear the internet is not going great, and so I am very glad that I pre-baked something. So I am not actually going to see demo 2. We'll use demo 2 today. So one thing that I will, this is my little crib notes. We've set up a whole bunch of tooling because we want people to get involved in this. And so one thing that you should note is that with these 3 things, fundamentally, we can just get a hello world in Rust WASM working. And so assuming you have cargo and NPM, you can also do this. And I'll be posting the tutorials along with my slides. All right, so let's hop into demo 2. Can everybody see? Awesome. All right, so if we take a look inside demo 2, if you've ever done any Rust work, what you'll see is primarily a Rust crate. Package JSON in Rust is cargo toml. Picking a markup language is hard. We can fight about it in the hallway. But when you write Rust, you're going to write your code in the source directory. And so we're just going to open that up. Whoop. So go into our source directory. And here I just have a lib, some utils that we kind of bake in for you. All right, let's hop into this. Before anyone comments on it, yes, I use Vim with no syntax highlighting. It's fine. Cool. All right, so this is our lib.rs. It's got 19 lines of code. The first 9 basically shouldn't matter to you. We're doing some cool stuff to make sure that you're allocating a little bit less memory. But those are all just nice to haves. The big thing that we have in here is our Rust code that is going to be using a very important web interface called alert. Who can guess what this would do if I ran it in a browser? Anyone have any idea? It will poof, it will explode your computer. No. Yes. It's going to pop up an alert, and it's going to say, hello, demo 2, which is not all that interesting. But if we take a look at this code, there's some interesting things happening here. We're using this as the kids call it, hashtag bracket wasm-bindgen, which is called an attribute in Rust, to kind of mark the touch points of where we want our Rust to talk to our JavaScript. And so if we look at 16 through 19, we are creating a function called greet, and we want that function to be available in the browser. So from JavaScript, I want to be able to call the greet function. And that greet function is going to call alert. But guess what Rust doesn't have? An alert function at all. But the browser does. And so we need to tell our Rust, which will then be compiled to WebAssembly, you don't have this here, but where you're going, expect it. It will be there, I promise. And so from lines 12 through 14, we've created an extern block. And inside there, we can just list our function signatures for the things that we expect to have. And so here I expected to have an alert function that should take a string. And you might see that that type is a &str. And if you've done Rust, strings are a little weird. I'm sorry, but that fundamentally just means it's a string. And so by doing so, we're able to compile this to WebAssembly, and it's going to make that greet function work. And it's also going to mean that when I call the greet function, it's going to go look in my browser for the alert function and call it with the string that I constructed in my WebAssembly. If you don't know how that's working, one, that makes a lot of sense. Two, that's what this talk is about. But I wanted to show you it working before I explain how it works. All right, so here we have our Rust, and let's compile this to WebAssembly. So we'll get out of here. All right, in here, so I have pre-baked this because I hear the internet is very bad. But what you would do is you would run a tool called wasmpack, which is the tool I wrote, which basically says, hey, I want you to make me a WebAssembly, but I don't want to like think about it that hard. And so wasmpack does almost all the thinking for you. And so you would run wasmpack build, and wasmpack build is going to create this pkg directory here. Let's poke in there and see what's in there. All right, there's a whole bunch of stuff. We got some JavaScript. We got some WebAssembly. We have a package.json. And we got a types file in there. That's pretty cool. So just for people aside, if you love TypeScript, wasmpack will generate type files for you automatically. But it's also going to build your wasm, and that's the wasm file right there, demo2_bg. But you'll also notice that we created some JavaScript. And that JavaScript is very, very heavy lifting. And it's going to allow you to interact with that WebAssembly. We'll talk more about that in a second. But let's see this working in real life. All right, so let's leave our pkg file or directory. And then we'll go into the www one. All right, in here, got a whole bunch more. We've got a webpack config. If you don't like that, please know you can use WebAssembly without webpack. It's just nicer with webpack. People have opinions. We got some other stuff in here, but fundamentally we have an index.html and index.js. I'll quickly show you the index.html. Nothing really fancy to see here. You see that we're loading something called bootstrap.js. Currently, WebAssembly needs to be loaded asynchronously. And we thought, hey, we always know how we need to load it. Why don't we just create a template so we load it for you? You can also load it yourself, but all bootstrap.js is doing is loading that WebAssembly for you. And then in index.js, all right, we can see that we are importing as wasm from demo2. And you might notice that we're importing from demo2, which is actually a JavaScript file. So we're using our WebAssembly via JavaScript, and we're calling wasm.greet. So that's a small tour of the code. Let's pop this open. I'm going to get, I should be able to run serve just here. Pop it up. Oh no, did my demo not work? That's terrible. Oh, right. I need to change one thing. No, that's correct. Shoot. Should I update that? Oh no, the demo gods hate me. Alas, that was supposed to be a beautiful, amazing alert message that we all really, really wanted to see. I know that's brutal. What the heck? Nope, that should all work. All right, well, I guess you'll just have to trust me that it works, because my demo is now not working, even though it just was. Do I need to npm install? Oh, here we go. There we go. I did the wrong thing. Yay! An alert message has never gotten that much applause ever before. Yay. For folks who are wondering what the issue was, I have another demo where I just serve it as a static site, but this one I needed to make sure that the Webpack magic happened, and so I should have run Webpack serve instead of just serve. But yes, here we go. We've got some stuff working. Hopefully this was a deeply compelling and not at all naive example that will make you desperately want to know what is going on under the hood here, because it turns out it's a lot. All right. So that is the thing that we all worked so hard to make happen. And while that was, of course, a very naive example, there's a ton of things that people are now building in Rust and WebAssembly that are not naive and are actually quite big and are production level applications, and it is super cool. But again, this is kind of where we started, because the stuff that's happening under the hood is pretty big. All right, so WasmPack is the kind of orchestration build tool, but under the hood, we're using a tool called WasmBind Gen. How many people here think that BindGen sounds like a city in Germany and not actually a technical tool at all? Yeah. So fundamentally, BindGen stands for Bindings Generator. And what I'm going to do is I'm going to talk about how we generate both Rust code and JavaScript code while compiling to WebAssembly so that you can talk to your WebAssembly as if it is JavaScript. And then I'm going to tell you why. All right. So again, Rust, WebAssembly, JavaScript. So, oh, hello. Anyways, so one of our primary design principles is the idea that WebAssembly should be an implementation detail. WebAssembly is super, super cool, but almost all of the things that are super cool and technical probably are things that most people, when they're using it, should never even have to think about. And so our first real belief was that WebAssembly should just act like a JavaScript module. We should just be able to interact with it like a module. You shouldn't really have to know whether or not there's JS or WebAssembly in there. And so when you're originally thinking about compiling Rust to WebAssembly, you may imagine that the process looks a little bit like this, right? You've got some Rust, you use cargo, you compile it to WebAssembly, and then you just kind of throw it into the lands where you heard that WebAssembly is supported, which, by the way, WebAssembly is supported in all of the major browsers, in addition to standalone runtimes and Node.js. But it turns out that this doesn't work super well. How many people have any type of JavaScript or web application static site on the web? All right, keep your hands up if it doesn't have JavaScript in it. Well, no, people put their hands down already. It's got JavaScript, I know it does. All right, this is really what the web looks like, right? So there is a universe where people believe that you're going to take an application, compile it to WebAssembly, just throw it up on the web, and you don't need to interact with JavaScript at all. But very few people actually have the privilege of being able to write a greenfield project. And the vast majority of people are dealing with legacy code. And legacy code on the web is written in JavaScript. And so when you have a universe like this is actually quite complicated, because the WebAssembly cannot talk to the JavaScript very well. And so what we have created, which I'm going to explain today, is how we take your WebAssembly, we jam it into a JavaScript module, then we generate a whole bunch of JavaScript so that when you send it over to the browser, everybody around it, all of the other JavaScripts, just like, hey, cool, this is a new kid, and he hangs out just like we do. All right, so again, to reiterate, we really need to interoperate with JavaScript, and this is why. This is module counts. I used to work at NPM. I don't know what is going on recently, and it's like I took this picture today and something happened with the stats. I don't know what's going on. But it doesn't matter what that last little huge jump is. NPM is clearly one of the biggest package ecosystems that exists. And regardless of whether or not you think it's full of garbage or not, I don't really actually care. It turns out that a ton of people are using this. There are around 9 million JavaScript developers in the world. Asterisk, I did a search for how many JavaScript developers are in the world, and then I just averaged the first 5 numbers I found. So I don't know, this jives with what I believe, though. The web is a big thing. We've already talked about what a delightful discovery and distribution mechanism it is. It does not surprise me that there's a ton of developers who are behind making that work, right? And what I thought was most interesting is that at least on the couple that had like the next languages in them, it seemed like it was around 2.5 million more than whatever they decided was the next most popular programming language. So there's a lot of JavaScript developers in here. How many people are hiring managers in here? All right. How many people who are hiring managers have to hire JavaScript people? Right? Yeah, okay. And it's also because there's a lot more of them, so they're a lot easier to hire. It's a lot easier to find a JavaScript developer than a Rust developer. And finding a WebAssembly developer, as I said, 10 years experience right here. No, I'm just kidding. So there's a lot of JavaScript developers in the world, which means that if you really want WebAssembly to be successful, you need to make that a tool in their toolbox, not a tool just for people who want to write systems programming languages and think that the lack of type safety in JavaScript is a huge security problem. All right? I know that you're out there, and I'm coming for you. All right? JavaScript's important, and WebAssembly will only be successful if we can make sure that it plays well with them. All right? Reiterating that. So as we move on from the idea that we really need to interoperate with JavaScript, we can talk more about our implementation details. And this is where I put a lot of code on the screen, and I try and do color highlights to make it easier. But I also kind of half expected to have my slides here so that I don't have a pointer. So you're just going to see wild hand gestures now. All right? So fundamentally, with this idea that Rust could compile to WebAssembly, we wanted WASM support to be unobtrusive, right? You should be able to write a Rust library that someone could compile to WebAssembly, but also could like just use in a normal Rust program. And it shouldn't be that implementing WebAssembly support would be so huge and obtrusive that it would like make it very unpleasant to have like a multi-purpose crate. Crate is what we call packages in Rust. I told you the puns were bad. Anyway, so we believed it should be unobtrusive. And as you saw from my demo, what we've been able to bring it down to is the idea that you're simply going to be annotating any type of public function that you wish to export with this wasm-bindgen attribute. And that is the vast majority of what you're going to have to do. All right. Now here's the big crux, right? I've been talking about WebAssembly needs to play well with JavaScript, and I haven't really told you why maybe it wouldn't, right? We need to work with and pass JavaScript objects into WebAssembly, but WebAssembly doesn't support that at all. Currently, WebAssembly only supports integers and floats. It only does numbers, is how I like to say it. And so maybe you're going to like put your nerd glasses on and push them up a little and go, well, actually, any type of programming could be expressed in only numbers, right? Of course. It's computer science. And I'm just like, nope, that is not a game that I'm here for. Particularly with WebAssembly being something for the web, I like to describe web development as fancy string concatenation. And I know I'm not wrong. I've been a web developer for a while. But if I had to take every single string I ever needed and convert it into a whole bunch of numbers to send it over a boundary, and then bring it back, take those numbers, turn them into strings, that sounds like a whole bunch of work, and I'm lazy. Who else here is a lazy programmer? Good. This is a value. Being lazy is good. About computers, not about people, though. Note that. All right? So fundamentally, what our desire was we need to enhance, all right, the ABI of WASM modules. Like I never thought I'd be saying like JavaScript has a rich type system, but if you take a look at WebAssembly, like, okay, it's relative here, but JavaScript definitely has like a significantly richer type system than WebAssembly, so we kind of need to enhance that. All right, and this comes down to the question of how do we shoehorn JavaScript objects into a U32 for WASM to use? And I am going to do a short tour of how we do that today. All right, so WebAssembly is also very interesting because it has something called linear memory, which is to say the way it thinks about memory is that it's just one big array. This is not really actually a simplification in any way. That's like kind of just really what it is. One of the things that I like to point out when I start kind of doing more like low-level programming is that it's not actually harder. I think it actually just gets simpler and just way more tedious, like very, very tedious. But the model here is like, it's just a big old giant array. And we got to put stuff into it and take it out. And the only thing we can put in is numbers. OK. By the way, this is I have like a side operating system project, and we kind of like mimicked a VGA driver the same way. You can get close to the metal, just playing around with arrays. It's fun. All right. So what we created with wasm-bindgen was what we call a polyfill for JavaScript objects in WebAssembly. So you may be looking at this slide and go, wait, Ashley, why did you cut and paste 2 little code snippets that are exactly the same? They are off by one very weird but load-bearing punctuation, which is the ampersand. And so I'm going to quickly just run through, because of this linear memory, the way we handle passing JavaScript objects in WebAssembly is going to be different depending on whether or not that object should live for a long time, which is the one over on the left, the one without the ampersand, or for a short time, which is the one with the ampersand. Alrighty. So again, we need to remember that we're dealing with one big array. And so what we end up doing is actually just making one big array in the JavaScript that we generate. And so I'm going to be showing you both generated Rust and generated JavaScript. And you'll see this consistently. But fundamentally, like, I am not lying to you. We're just talking about big ol' arrays. All right, so let's talk about short-lived JavaScript objects. So here is a bunch of code. So what we'll see here, I wish I had like my mouse pointer, it's kind of tricky. So the Rust that we're going to write is where I have this foo.rs. We have our foo function. I don't like using foo for examples, but this is actually supposed to be as generic as possible. So it actually, I think, kind of works here. And so you have that annotation. And we're writing this because fundamentally the TypeScript or kind of JavaScript interface we want is we want to be able to just kind of export this function, and it can take any sort of JavaScript value whatsoever. And so in order to make this happen, you're going to write that Rust, and then this is what WasmBindGen is going to create. The first thing it's going to create is this generated Rust. And so what you'll note here is that your original function still exists and is completely unmodified. It's a pub fn foo, still right there. However, right below is a very funky looking function. We can see we have a pub extern c. All right, so this is where we're kind of defining this boundary. And the function actually has a generated name. So if you go and use the toolchain that I just showed you, the generated files, you're going to see like a checksum in the name. You're going to be like, I hate this function signature. It's a gross number. And that's because it's generated, and you shouldn't touch generated files. But here we're going to be exporting this as foo. That will be the name still. But what we can see in here is that we are actually going to be grabbing some data from our giant array. We're passing it an index. And that index is going to be where all of our file for our string, our data for our string is going to be, or our data for our JS value. And so you're like, OK, Ashley, what do you mean that data for your JS value? What is going on there? And so what we can see up in foo.js, all right, which is JavaScript that we also generate, all right, we're first constructing this new array, which is going to be our heap. For short-lived JS objects on the stack, we're actually going to treat the first set of that array actually kind of as a stack. All right, and so when we add a borrowed object, which is going to be this object that we're trying to call our function with, we are going to pop that right on there, and it's going to operate the same way as a stack. You push them on, you push them off. All right, and fundamentally, this means that that value is not going to be available once that function gets called. Right, it can't be long-lived. It's only going to live for the duration of that function. All right, and so I wish I could point a little better, but in our JavaScript, and this is the JavaScript function you end up calling as an end user, export function foo. All right, the first thing that we're going to do is we are going to create this index. And this index actually calls this add borrowed object, right? So we have this arg0. All right, and what that's doing is it's taking the object, all right, and it's going to pop it onto the stack that's in our heap array. And then we're going to use that index. All right, we're going to call foo with that index. It's going to pop that right off. It's going to do the thing it needs to do. And then we're going to immediately erase it from our array. That's what's going on in the finally section. And so what you can understand is we just have a big ol' array. We have this JavaScript. We're going to add the borrowed object. All right, and then we're going to pass that index of where we've stuck it in memory to our wasm function. And then our wasm function is going to use that index to pull it right back out and be able to call it. But fundamentally, this memory is being managed as an array, and we're really passing around indices. And what you'll see when we talk about the long one is that you're going to be passing around indices and lengths. Cool. Yeah, and just to kind of like check in on exactly what's going on here, right? We wanted export function foo. The foo function that we call comes from generated.js. All right, that generated.js is going to be calling wasm.foo, and that wasm.foo is actually a generated function from Rust, which then ends up calling the Rust that you wrote. Man, that's a whole bunch of stuff, right? That probably didn't make a whole bunch of sense. You have to kind of read these things over and over a couple times to get it. It can get a little much. So I got some arrows, but let's not talk about those. All right, and so for long-lived JavaScript objects, I won't settle on this too long, but what I do want to point out is that for these, instead of kind of popping them in that little stack we created at the front of our array, we're actually just going to be pushing them onto that array, and they're going to be staying there for a lot longer. And again, to access them, we're going to be saving an index and a length so that when we call it from WebAssembly, WebAssembly is going to go look into its memory, figure out that indice that JavaScript passed it, grab all of the data, and then pull it back out. But everything is stored as just these numbers in this array, and you're passing around indices and lengths to do so. All right. This is a bunch of code. And then additionally, because it lasts for a long time, we actually have to kind of manually manage the memory by removing it from that. So for long-lived JavaScript objects, this gets a little bit trickier. And so as you're writing WebAssembly, as a practical takeaway, you kind of want things that live short, and you don't want them to persist as we go back and forth between Rust and JavaScript, because we call that the trampoline, and like crossing any type of border, it's complicated, and it takes a long time. All right, but let's try and use something that maybe is a little bit more concrete. Like, we don't want to talk super generally about how we're crossing this boundary. Let's talk about just exporting to JavaScript, right? So if we export to JavaScript, let's say we have this greet function, right? So I want a wasm function that works like this. I want this greet function. I'm going to say alert. It's going to have a name. All right, and so I'm going to write Rust like this. This is the extern that we already saw. And fundamentally, we want to be able to use it in JavaScript like this. So what happens? All right, we write this, and then what Rust does, and fundamentally what you need to realize about what wasm-bindgen is doing is that it is writing a wrapper around your Rust, and then it's also writing a wrapper around your WebAssembly in JavaScript to make these things play together. And so the first thing, again, we see our greet function, but then we see that generated greet. And again, it's taking that pointer, and it's taking the length. And again, that's how we're noting what that data is. And then if you take a look at alert, we're actually creating a placeholder. And we're being able to pass that data into the placeholder with WebAssembly knowing that it's going to have to call that from your browser. All right. And then when we look on the JavaScript side, we have this JavaScript that we'd really like to write, a nice simple interface. And fundamentally, again, we see this manipulation of the pointer, which is really just the index of where it is in the array, and then the length of where that data is. And so this is what it is called. And so I would encourage you, as you use this toolchain, if you ever want to peer under the hood and take a look at this code, you should try and understand at least kind of how it's kind of stringing everything together. Because fundamentally, as we move into WebAssembly being something that everyone is using, the more you know about how this works, like it's just array manipulation, and there's definitely ways to do it more efficiently than we currently are. And so this is a place where I think speeding up WebAssembly could be made so much better if we just had more eyes on it. All right, so again, you'll see when you create something like this, these functions called pass string to wasm, get string from wasm, and we are using text decoder right now to kind of take those from strings, put them in numbers, take them from numbers, and put them into strings. Now what you need to realize is this was a whole bunch of work, and this is just strings. Right now, wasm-bindgen supports literally every JS API, Web API, and the ECMAScript standard for being able to convert like a Rust function signature into a JavaScript one. And so there's some really beautiful moments where you go, whoa, like what? How do we teach Rust to pretend it's doing JavaScript inheritance? Because we do that. But there's a lot of very interesting lessons in there that would take, unfortunately, an incredibly long time to explain. But the real thing here is to say the best part about all this random generated code, manipulating arrays, you saw some unsafe blocks in there and probably didn't know what they were, but assumed they were bad, and you're not wrong. The best part of this is that it's designed so that you literally never have to think about it if you don't want to. If you just want to build cool web apps and you want to be able to write it in Rust and you want to talk to it like JavaScript, you just can, right? Like, you can peer into the box, like this bird here, and maybe you see something you don't like. Maybe you did not like that last 20 minutes, right? It kind of bummed you out. Just close the box. Just close the box. It's totally OK. But sometimes it's fun to open the box. I love this GIF. It's just, this is how I feel about looking at my own code. Yeah, it's just like, nope, close it. Cool. All right. So why would we do all of this weird work? Like, this was so much effort to make WebAssembly talk to JavaScript. Like, why would we do that now? That was like so much. Why would we do it? And it's because WebAssembly isn't done. My favorite thing about the web is that we are still building it. And the cool thing about the web is that you can help people build it. WebAssembly is just getting started. The thing that's been released is not final WebAssembly. It's the MVP, really. And so I don't know if you know Lynn Clark, but also Till Schneiderheit, Luke Wagner. I worked with them all at Mozilla, and they are brilliant people. Lynn loves to draw code cartoons about WebAssembly, and they are awesome. And so WebAssembly has a lot of growing to do. In fact, this is kind of a map of the growing that the WebAssembly wants to do. But the interesting thing about languages and their growth is that in order to get people to be willing to participate, particularly like a larger group of people, you have to give them a way to use it, right? And so this is very close to me, but the keynote here is called We Are Not Waiting, and it's about the open pancreas system. And it's about why type 1 diabetics are not waiting for this cool technology to like become approved by the FDA. They're just starting to hack on it and use it now. And I feel that way about WebAssembly right now, which is I'm not waiting. Like, eventually, they're going to build something. But it's really cool that I'm alive right now and that maybe I can help them build the thing that I think they should build, or like be able to participate. And so we need to get people starting to use it now. The best thing about wasm-bindgen is probably in like 5 years, it will be completely unnecessary. And that's awesome. Like, that's so cool to build this type of technology where like you can already tell it won't be necessary, but it will have helped so many people get involved so that they could have helped make WebAssembly a tool that everyone's going to love. Like, a lot of people in here really hated on JavaScript, right? And it was kind of hard to get involved in JavaScript when they first released it, right? It'd be harder to be mad at it if you had an opportunity to participate that you didn't take, right? This is that moment for WebAssembly. And so this is your opportunity to get involved. And a really great way to get involved is just to try it out. So you can help by joining the WebAssembly working group. We spend a lot of time working on this stuff, tooling what is the thing that we should build. Right now, WebAssembly there's a lot of really awesome people in it, but people are really focused on the technical details, and they're not at all focused on the part about like how people use it. Adobe Flash succeeded because it was an amazing developer experience, right? It exceeded for so long because it was such a good developer experience, even despite like pretty much everything else being a pretty bad design decision on their part. So I want WebAssembly to succeed, which means people need to be able to use it. There's also WebAssembly.org. You can submit feedback and issues, and you can join the community group as well. These are all open to anyone. And so I'll leave you this. I have a lot of passion about this, and you probably are like, why does this lady care so much about WebAssembly? She loves it. What's the deal? All right. So I care a lot about building tools that people use. This is a tweet of mine that went viral, and you know it went viral because there's a typo in it. But the cartoon says, I like this painting because it has a bench. And I feel that very heavily. And the cool thing about jokes is like it's hard to know if they mean it positively or negatively. And when people like the joke, you still can't tell how they feel about it. But to make it clear, I build benches, and that's what I care about. And I think that that's the way to make technology that's successful. So the HTML5 design principle spec says, in cases of conflict, consider users over authors, over implementers, over specifiers, over theoretical purity. And I feel like we should all follow this design principle all the time. which is to say, I want people to use this tooling, and so we're going to do that huge song and dance with that array because I care more about you being able to use it than the pain of actually implementing it. And so I want to do a small tour of these tools that I've talked about before I leave. First off, we have wasm-bindgen Gen. This is a very fun code base. If you want to read the tests, they're like organized just by the types of JavaScript APIs. And like literally, there's string concatenation with how we write the JavaScript. And so it's just fun to see that. This is wasmpack. This is the tool that makes it so that you don't have to worry about this tool at all. But it will do it for you, which is super cool. And you can publish your stuff up to NPN if you'd like to do that. Additionally, if you were wondering if we can turn Rust futures into JavaScript promises, we can. You can use this to do it. It's getting there. We just got some good news for Rust async, so it will be better soon, but you can do it. Additionally, when I showed that example, I wrote an extern block and wrote the alert. And if you maybe in your head went, oh, shoot, do I have to literally define every function signature of every API I expect to use in my Rust? No. But at one point you did, and it sucked. And we were like, we got to get rid of that. So this will do all of that for you. So if it's anything in the ECMAScript standard for browser.js, this will just make those for you. You can just import the function signatures. You can just be like, I want to use this, and it will be fine. We do the same thing for WebSys. But just because a lot of people don't know this, well, first, how many people know what a WebIDL is? Fair. Pretty much no one does. Like, what if the spec actually compiled to code? Is kind of the pitch for WebIDL, but it's a way to programmatically define the web APIs. And so we actually generated WebSys with some difficulty, but we pulled it off. How many people here have heard that WebAssembly can't access the DOM? All right. If you get into WebAssembly, people will say that. It's true it doesn't have native access, but with WebSys you can, and that's pretty cool. And then lastly, what if React was written in WebAssembly, or just little pieces of it? We're building this. It's called Glue. Check it out. And then lastly, I got to pitch my company, I guess. If you want to write Rust and WebAssembly, you can also do it on Cloudflare Workers. And I made another CLI with another crab logo because I'm insufferable. All right. So to wrap this up, WebAssembly should be an implementation detail. Most people should never know they are even using WebAssembly. And I think that that's its power and not necessarily a curse, though certainly growing the technology makes it difficult. We're going to see a lot of really cool things come onto the web, and it's going to be unlocked by WebAssembly. But realize that with this power, I want to make sure it's inclusive to all types of developers and not just the types that want to, it's fine, I can convert all my strings to numbers, I don't care type person. I want it to be accessible to everyone. And so that's why this developer tooling really matters. So let's go forth, make amazing things that expand the web platform. Or if you came here because you didn't really care that much about WebAssembly, try to teach some languages how to talk to each other. You will learn so much. Translation projects are some of the best possible ways to learn languages. I know I learned a lot about both JavaScript and Rust working on this project. And so if you're looking to get to know languages better, translation's an awesome activity. Thank you very much.